Okay, well, now we're going to start next chapter, and we're going to talk about polynomial and rational functions. So some of these you've seen before, so it should be a review, but then we'll get into things that you haven't done or haven't done much of. And then we'll talk about rational functions, which you probably haven't dealt with much at all. So in the first chapter, we talked about lines. I think we talked about lines, did we? Let me just look here. I don't know if that was in the review, if we actually talked about it in here. Functions, linear equations in two variables, so we did talk about that. So next thing we have is nonlinear equations in two variables, the variables being y and x. And for the most part, they're what we would call explicit functions. When we solve for y, so y is on the left-hand side of the equation, and x, some equation involving x is on the right-hand side. Just to expand on that point before we move on. So let's say you have y equals 3x squared. So that's what we would call explicitly solve for y. Now if I had y squared plus 3x squared equals 7, that would be an implicit equation because we haven't solved for y. And this actually wouldn't be a function, but this would be an implicit relationship. So, and it doesn't mean that you can't deal with these things. It's just different. Okay. So here's quadratic function. So it's a cannot be 0 because if a is 0, then it becomes a linear function. But otherwise, a, b, and c can be any real numbers. And the general shape of a quadratic equation, f of x equals ax squared plus bx plus c, is this shape. We would call it a parabola. There's a minimum or a maximum, which we would call the vertex. So there's no values. The range is limited to in this case x equals 1. It looks like, or y equals 1. Everything, all the function values are above y equals 1. The domain would be all real numbers, which I think I specifically say in the next slide. This function would have both a and b and c because of where the vertex is positioned relative to the origin. So this is the case here. If a is greater than 0, then it points upward. And if a is less than 0, negative number here in front of the x squared, then it should be pointing down. So here we have a minimum vertex is here. Here we have a maximum vertex is there. In both cases, we have this line which we call the axis of symmetry, such that if you go equal distances on either side of the x value for the axis of symmetry, the y values are the same. So for example, if I go 2 units to the right here, you can see where it intersects the y-axis. If I go 2 units to the left, it has the same y value. So if I knew the y-intercept here, and I knew where the vertex was, I could go over here and just go the equal distance and find another point to plot. Now, to actually plot these things, the things you're looking for are things like the x-intercepts. Here there are 2 x-intercepts. Here there are none. The vertex, which is that point, and the y-intercept, which usually then gives you another point. So you can at least find 3 points. This, and that. If it's either this dips below the x-axis, or when it's inverted like this, goes above the x-axis, then you have 5 points. The 2 intersects. The y-intercept, the point that's symmetric around the axis of symmetry, and the vertex. And then you have one that's symmetric around the y-axis. That's where both b and c equals 0. A to point up, a has to be greater than 0. And what the value of a does is it shows you how quickly it increases. So it could go more slowly or it could go more quickly. I think in this case it's probably a is 1. So that's your standard simple parabola, f of x equals x squared. So that you get 1 comma 1, and you get 2 comma 4, and so forth, and you get negative 1 comma 1, negative 2 comma 4. And you got the x-axis here, or the vertex. Likewise, if a is less than 0 and you don't have any b or c, it's just going to be pointing down. Again, the magnitude of a tells you how quickly it increases. So here you can see if a is 2 versus a equals 1, it increases more rapidly. So this parabola is steeper. And that's because the y value is twice the y value would be here. So for x equals 1, here you get 1 squared, which is 1. Here you'd have x squared, 1 squared, which is 1 times 2. So it would be 2. So you can see that happening here. So at x equals 1, the standard parabola is 1. 2x squared is twice as much. Here you go to 2, 4, and then it would be 2, 8, which is kind of off the screen here. Now to be able to plot the vertex, which is extremely critical, is you want to put it in standard form. And standard form is as such. You have a constant multiplied by a x with a coefficient of 1 in front of it, minus h, quantity squared, plus k by itself. And h is horizontal shift. I think in the previous chapter, they were in standard form, but a lot of times they're not in standard form. So by putting it in standard form, you'll know where the vertex is. If a is positive, then it'll be pointing upwards. If a is negative, pointing downward. So in this case, the way it works is if we could factor this initially, which in this case you can, so you'd have x minus 4 times x minus 4. So that's factored. Because it's the same factor, you get x minus 4 squared plus 0. I just put the 0 there so we can see what k is. So what we have is h is equal to 4 and k is equal to 0. So this is the x shift and this is the y shift. It's also the coordinates of the vertex is going to be 4, 0. So the way you could, if I just went over here and I just kind of traced over top of the, so let's use this purple here. So if I trace over y equals x squared, which is a red curve, like that, not very good, but so what I could do is then take that curve and I would move it to the right 4 units. 1, 2, 3, 4. It's not displaced vertically. And the coordinates of the vertex are 4, 0. Now all the other parts relative to the vertex are the same. Here we went over 1 up 1. So you get over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4. Symmetric around the line x equals 2. So you can take, actually x equals 4. This x minus 4 is actually the equation for the, so if you say y equals x minus 4, actually what you do, that's not right. So what you do is, well, I guess you could take that, set equal to 0, x minus 4 equals 0, or x equals 4. So this line here is x equals 4. So the vertical line is just a line with the value equal to x equal to the value of the x coordinate of the vertex. Okay, so now here's one that we can't factor easily. If you think about it, 7 is 1 times 7. 7 plus 1 is 8. That's not 8. Okay, so how do we do this? Well, we use something called completing the square. You could use the quadratic formula, but we're going to use completing the square, which we use a lot in calculus, so it's something good to learn. So what we want to do is we want to add a number here so that we can reduce this to a complete square. What is a complete square? It's where you have one factor and it's squared. So x plus or minus something squared gives you that, plus another number. So the procedure is you take this coefficient, and if it's even, you're happy. If it's odd, it's still doable, just a little more trouble. So you take that number, 4, divide by 2, always 2, square it. That's 2 squared, which is 4. So we add 4, but you can't just add something without either adding it to both sides or adding it and subtracting it. So we're going to add and subtract from the same side, on the same side. So 4 minus 4 is 0. So the thing stays the same. And if we bring this around here, well, actually we can now make this complete square. And it turns out this number here is the number that goes there. So it's plus 2. So we're going to put x plus 2 squared. And then you do the math over here. 7 minus 4 is 3. So what we can say is f of x equals x plus 2 quantity squared plus 3. Or we could say x minus a negative 2 quantity squared plus 3. So what I've done is I've tried to get it in standard form, which means this has to be negative. This is positive. So what you do is you factor out a negative, and that means you've got a negative still in here. You can see negative times a negative is positive. So now that's in standard form, and so it's easy to see that h is equal to negative 2 and k is equal to 3. This is h, x minus h, and then k is this thing we add on here. So the coordinates of the vertex are going to be negative 2 comma 3. The equation for the line of symmetry is x equals negative 2, the axis of symmetry. Now, so that's the standard form, but let's just go one step further. I said knowing the x-intercepts and the y-intercepts were important. The y-intercepts is best just to go back to the original function and say what's f of 0. So that's 0 squared plus 4 times 0 plus 7. So that's my y-intercept is at y equals 7 or x equals 0, y equals 7. So that's a point on the y-axis. Now the x-intercepts, what you can do, it's easy, probably best to do it at this point. So there you just set, you're setting y equal to 0, or you're setting f of x equal to 0, same thing. So we just set this equal to 0. So you get 0 is equal to x plus 2 squared plus 3. And then we take the 3 to the other side. And then you take a square root, and you're going, I can't do that. Can't take the square root of a negative number. So because of that negative sign here, what we can say is no x-intercepts. And you'll, if you take a piece of graph paper and just plot the two things that we know so far, and we'll use, minus 10 plus 10, 10 minus 10. So the y-intercept was 7, so that's right up here. And the vertex is negative 2, 3. Negative 2, 3. So plot that. -2, 3. So there it is. So what that means is, and A is A is 1. So it's positive. It means it's going to go up. So you can see that there's no way it could have x-intercepts. But one last thing, two things we can do. We can draw the axis of symmetry, which is a line here. So that's the line x equals -2. And this point, the y-intercept, there's got to be a symmetrical point. So you can see what I can do. I can go from the vertex over 2, up 4. So I can go over 2, up 4, get right there. You could also plot this point because this coefficient is 1. It's going to be a standard parabola with the standard relative positions and everything. So that's what it looks like. And I'll just prove that it's right by plotting this thing on our graphing program. So what was the original function's name? So back here, x squared plus 4x plus 7. Okay. X squared plus 4x plus 7. Graph the thing. There it is. Let's zoom out in the x direction. So there it is. Let me just try to get it so we get integers instead of, there we go. So you can see it intersects at y equals 7. Here's the vertex, -2, 3. Here's that other point, which is -4, 7. Those 2 points are symmetric. Okay, so this is what we just did, but it's kind of formalizing the whole thing. So standard form, a cannot equal 0, or it's not a quadratic equation. Once you have it in standard form, h and k are the coordinates of the vertex. K is the vertical shift, h is the horizontal shift, a is the vertical shrink or stretch. If it's greater than 1, it's a stretch, and if it's between 0 and 1, it's shrink. If this is positive, then it's pointing upward. If it's negative, then it's pointing downward. The line x equals h is the line of symmetry, axis of symmetry, and you can set x equal to 0 to find the y-intercept, but sometimes it's easier to put it into the original equation instead of the standard equation. And then you set this equal to 0 to find the x-intercepts, and you can use, bring this over to the other side, divide by a, take the square root, and that works. As long as you don't get a negative square root of a negative number, then you say, okay, I don't have any intercepts. Okay, so let me just delete this one, and we'll do it. It says you graph the utility. Well, yeah, we're gonna do it analytically, and then compare it. Okay, so what do we do here? Well, it's not in standard form. So what we might do is take this 3/5 and take out this term. So you'll have plus 3/5 times -5. So you can see those cancel out and become 1 and the negative sign. So you end up with 3/5 x squared plus 6x minus 3. So that's the function. All I've done is taken this term, separate it out, simplify it. Now I need to complete the square inside the parentheses. So I take my coefficient 6, divide by 2, square it. 6 divided by 2 is 3. Square that, which is 9. So I add 9 here. But really what I'm doing is I'm not really adding just 9. I'm really adding 3/5 times 9, which is 27/5. So since I'm adding 27/5, I need to subtract 27/5. Okay. So then what we'll do is we can complete the square here. So it's going to be 3/5 times x, and take this number 3 plus 3 squared. And then what we have here are -3 minus 27/5. So we convert 3 into fifths. So that's -15/5 minus 27/5. And you add 15 and 27, you get 42. So it's -42/5. -42/5. So there we are in standard form. So what can we say? Well, we can say we're going to have a horizontal shift. Well, one last thing here. Let's do f of x equals 3/5 x minus a -3 squared minus 42/5. So x minus h. So h equals -3. So that means shift left 3. Then we have a vertical shift is k. K equals -42 or 5. So we're going to shift down 42/5, which is approximately, let's see, 8 point something. The coordinates of the vertex is going to be h comma k. So that's -3 comma -42 or 5. The axis of symmetry is x equals -3. The y-intercept. So if we go back here to the original equation, we put in 0. All we have left is -5, and -5 times 3/5. So that's going to be -3. So it's going to be 0 comma -3. And then the last thing is the x-intercepts. So to do that, we take the equation in standard form, and we set that equal to 0. I'm going to go ahead and change this to a plus. So take that to the other side, make it positive. And then we're going to multiply by the reciprocal of that, 5/3. 5/3. So that'll become 1. Here the 5's cancel out. 42 divided by 3 is 14, I think. 14 is equal to x plus 3 squared. Take the square root, so you get plus or minus the square root of 14 is equal to x plus 3. Or the x-intercepts are -3 plus or minus the square root of 14. And we'll just calculate what those are. So -3 plus the square root of 14 is 0.742, and taking the negative square root, you get -6.74. Okay, so let's look at the graph now, confirm everything that we've done here, make sure it works out. Okay, so the vertex is -3, 1, 2, 3, -40, -8 point something, 2, 4, 6, 8 something. Okay, so that works out. Check. So the vertex is that. We have a axis of symmetry that is the vertical line x equals -3, so that checks out. We have a y-intercept of -3, which is right here. Notice this is 2, 4, 6, 8, negative. So that's why. Whereas here it goes from -10 to +10. Okay, so the x-intercept's right, the y-intercept's right, and the x-intercepts are 0.4. Is it negative or positive? Positive. So right here, you can see here's 1, here's 0, so that's about 0.742. And if we go the other direction, we get something. What did I do? I did something wrong there. 3 minus the square root of, I got -6. Does that make sense? Oh yeah, it is. 1, 2, 3, 4, 5, 6. 0.74, so that works out. So everything, and then you could have one, you could take this point of symmetry to do that. So these are the points that we plot, and that would be the resulting. And and this is my axis of symmetry. So let's do another problem. So it's a quadratic equation, but it's again, it's not in standard form, so we have to convert it into standard form. Remember, standard form is a times x minus h squared plus k, where h and k are the vertices. So we take our original function, and we're going to leave a space to complete the square, and then just write the third term over there. So we take 4, divide by 2, square it. That's 2 squared, which is 4. So we add 4 here. So let's put a little green, plus 4. And then we subtract 4 to balance that out. So now we can take the first 3 terms and we can write that as a complete square, and it's going to be x plus this number, 4 divided by 2, which is 2, squared. And -3 minus 4 is -7. So now it's in standard form. What we have is a is equal to 1, h is equal to -2, and k is equal to -7. Now remember, this is x minus h, so really if we want to put it in standard form, we'd have x minus a -2. X plus 2 is the same as x minus a -2. And now you can see that h is -2 and k is -7. So what we can say is that the vertex is the point -2, -7. It's pointing upward because a is positive. It's +1. So, this vertex is below the x-axis, and if it's pointing up, we're definitely going to have x-intercepts. So let's do the x-intercepts. What you do is you set the equation in standard form equal to 0 and solve for x. So move this to the other side. We get 7 is equal to x plus 2 squared. Take the square root. So you get plus or minus the square root of 7 is equal to x plus 2, or solving for x, you get x is -2 plus or minus the square root of 7. The axis of symmetry is going to be x equals -2. From this, from that, all different kinds of reasons. Okay, now let's just go ahead and figure out what the decimal equivalent of those -2 plus the square root of 7. So we get 0.65, and if we do the negative square root, we get negative 4.65. 65. Okay, so that's the x-intercepts. You know, it's going to be 0.65 comma 0 and negative 4.65 comma 0. So those are the actual points. We have the y-intercept, and you go back to the original form of the equation, x squared plus 4x minus 3. So you set x equal to 0, so the y-intercept is y when y equals negative 3. Is that right? Negative 3, yep. The point is 0 comma negative 3. And I think that's all we need. Let's see, what else did I ask here? Vertex, got that, x-symmetry, x-intercepts, y-intercepts. Okay, so we're going to add a page and put a piece of graph paper in. Okay, so our x-intercepts, and let's make this negative 10, make this positive 10, 10, negative 10. Okay, so, well, let's go back to the vertex. Vertex is negative 2, negative 7. So we go negative 2, negative 7. So there's our vertex. The y-intercept is negative 3, which is right here. The x-intercept is 0.65, which is about here. The other x-intercept is negative 4.65. 1, 2, 3, 4.65. The axis of symmetry is going to be right through here. So here, if we go to this y value where we have the y-intercept, and we go the same distance on the other side, so we go 2 this way, so we go 2 that way. That's using symmetry to get some additional points. So you can see what we have is a parabola that looks something like this. Now, there's actually, because this a is 1, we can use the normal situation where if you go to the right of the vertex, you go up 1. If you go to the right of the vertex 2, you go up 4. 1, 2, 3, 4, which is the y-intercept. So we do the same thing on this side here. Up over 2, up 4, over 3, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Go over 3. 1, 2, 3. Is that right? 9. Yeah, 3 squared is 9. I was doing 2 cubed. So 3 cubed, 3 squared is 9. 1, 2, 3, 1, 2, 3, 4, 6, 7, 8, 9. So that one, and then do the same one over here. 1, 2, 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The next one will be 4, 16, which I think will fit. So it's 1, 2, 3, 4. So that's 7, 9 is 16, and the same thing over here, so that gives us some additional points. Like that, like that. Okay, now if A was something other than 1, then it wouldn't be quite as simple to do that. Okay, so let's do one additional problem, which I don't think I've assigned it. Well, I'll assign a homework problem like this, but it's finding the quadratic function that has the given vertex and it goes through a specific point. So what the vertex does is it gives us h and k. So h equals 4 and k equals -1. And so you take the function in standard form. So you have a times x minus h. H is positive 4 square plus k plus -1. And so we have h and k, but we don't have the a. And we can use this point to figure out what a is. So all we do is, remember, f of x is y. And this is x. So we use that for the x value. Use this for the y value. So when y is 3, x has to be 2. And you can see that I can now, the only unknown is a. So I get 3 is equal to a times -2 squared minus 1. What I'm going to do is I'll move this to the other side. So that'll be 3 plus 1 is equal to a times -2 squared, which is 4. So left hand side is 4. I get 4a. A is equal to 1. So this is the standard. So now we can say it's equal to 1 times x minus 4 squared minus 1, or you can leave off the 1. And we can double check this by plotting this function, x minus 4 squared minus 1. So it's x minus 4 squared minus 1. Graph it. So there it is. 0.2 comma 3. 1, 2, 1, 2, 3. There it goes. It's right through that point. You can also see that it would have an x-intercept of 3 and 5. And if if I picked another point, let's say instead of 2 comma 3, which is right here, if you chose, say, 1 comma 3, then it would be stretched in the actually it'd be in the y direction. It would be shrunk because it would move down this way. So we should end up with a fraction. Let's just try that. So let's redo the problem, and instead of 0.2 comma 3, let's make it 2 comma 4. So again, this is the x value, that's the y value. So when you get to here, you say y equals 4 equals a times x, which is still 2, minus 4 squared minus 1. So when you move 1 to the other side, you get 4 plus 1 instead of -1. So you get a, and then 2 minus 4 is -2. -2 squared is 4. So you get a is equal to 5/4. So then the equation would be equal to 5/4 x minus 4 squared minus 1. Now, the thing that's bothering me is I was expecting this thing to be smaller. So did I do something wrong here? Well, let's just plot it and see what happens. So all I really have to do is just put 5/4 in front of the equation here. So I say 5 divided by 4 times that. Oh no, the example I was doing, I was moving it up. So it was stretching it. So you can see now it goes through 0.2 comma 4 instead of 2 comma 3. Okay, so that's pretty much it for that section. So what do? We said you had to put it in standard form. From there you can find the vertex. Then you can find the x-intercepts by setting the equation standard form equal to 0, solving for x values where the function is 0. That's your x-intercepts. You can go back to your original equation that's not in standard form and just set these equal to 0, so the constant term is your y-intercept. The x-coordinate of the vertex is also the equation for the axis of symmetry.